Alright, class. Um, let us now have first law of thermodynamics. So let us have the closed system and the open system. So you have it in your handouts already, the closed system. So let me have a quick discussion about this one. So conservation of energy principle. Energy can neither be created nor destroyed. It can only change form. So I guess we are very familiar with this principle already. Energy cannot be created nor destroyed. It can only change from one form to another. So we have here a closed system. The energy balance of a closed system states that the net change, when I say net change, it could be an increase or a decrease in the total energy of the system during a process is equal to the difference between the total energy entering and the total energy leaving the system during that process. So in symbols, we have energy entering minus energy leaving the system. Mao na siya ang delta E of the system or the change in the total energy within the system. So we have here an illustration. So again, this is a closed system class. So ang atuang energy entering the system is in the form of heat, and energy leaving the system is in the form of work. So in this case, since we have a closed system, this work is a non-flow work or a work non-flow. Okay, this is a work non-flow. So again, ang atuang energy entering is in the form heat minus energy leaving the system in the form of the work non-flow. That is your delta E of the system. So rearranging, we have heat now is equal to delta E of the system plus a work non-flow. So we have here heat, the change in the total energy within the system. The total change of energy within the system is composed of the total delta U, that is internal energy, plus the delta potential energy, plus the delta kinetic energy. So again, work non-flow, since we have here a closed system. Work non-flow, also, this one, is composed of the boundary work plus other forms of work. So by the way, just a review sa topics sa work, we have boundary work is we can get the boundary work using the formula integral of Pdb, that is from B1 to B2. And it also comprises other forms of work. This one, class, it depends kung ihatag siya sa problem, this part. So, we have work of acceleration, gravitational work, we have shaft work, electrical work, so other forms of work. But if wala gani siya gi-indicate sa problem, so it could be 0. So automatically mo siyang i-0. That is why ang imong work non-flow na will be just equal to the boundary work, which is the formula integral of Pdb. Okay. So for a stationary system sad class, so stationary system, your delta P, or the change in potential energy, and the change in kinetic energy is approximately 0. Or if it is 0, therefore, ang imuhang delta if the system now is just equal to the internal energy, delta U. So, ang atuang equation will be further be this one. Heat, nahimo na siyang heat na to is equal to the delta U. So, ang delta E of the system is na substitute na to sa delta U plus the work non-flow. So, this is now the energy balance for a closed system. Heat is equal to delta U plus work non-flow. Or in differential form, we have this one. dQ is equal to du plus the differential work non-flow. Now, let us proceed to an open system or control volume. So, an open system, it could be a steady flow or an unsteady flow. We have the conservation of mass principle for this type of system, which states that the net mass transfer to or from a system during a process is equal to the net change, that is the decrease or increase, in the total mass of the system during that process. So, unsa ko na to? The conservation of mass principle in equation form, that is mass entering minus mass leaving the system, that is the delta mass within the system. Or in terms of flow rate, mass flow rate entering minus the mass flow rate leaving the system is equal to the change in the mass flow rate within the system. So again, unsa ni siya? Mass flow rate na siya. Mass flow rate na siya dot sa ibabaw. It is the mass per unit time. Okay. Next, we have the energy balance. For a steady flow process class, your change in mass is equal to 0. So therefore, your mass entering is just equal to the mass leaving the system. Now, for the energy balance of an open system, the net change or the increase or decrease in the total energy of the system during a process is equal to the difference between the total energy entering and the total energy leaving the system during the process. So basically, same result siya sa closed system ang iyahang general nga definition sa iyahang energy balance, that is the delta E of the system is equal to the energy entering minus the energy leaving the system. So that if we try to illustrate this one, so entering now is in the form of heat. So at the inlet also we have these different properties of the system. We have the potential energy, the kinetic energy, we have internal energy, we have the flow energy, all at point 1. Then maybe you have also the elevation, Z1. And for point 2, we have the energy leaving the system, that is the work. And we also have these different properties. We have potential energy, kinetic energy at point 2 now. U2, we have flow energy at point 2. And maybe we also have the elevation at point 2. Okay. So that if we have now in equation form, so by looking at the illustration, ang energy entering the system now is heat plus P1, potential energy at point 1, plus kinetic energy at point 1, plus U1, plus the flow energy at point 1. So, kanini ang EF plus the flow energy, that is equal to the product of pressure and the volume. Okay? Also, kung ato na siyang i-substitute, that is Q plus P1 plus K1 plus U1 plus P1 V1. And we can also substitute this quantity internal energy plus PV, since we have the term enthalpy is equal to the sum of internal energy plus PV. So we can substitute that also with our equation now, E1 K1 plus H1. Okay. And kanisad siya na siya, this is also collectively known as methyl free. methyl-free, or beyond enthalpy, that is P plus K plus H. So we can also substitute that one, but let's just not substitute, or you can also substitute that in your equation, or if maybe you see this term, this variable used in the problem, so you can have that relation. So we have now the energy entering the system. What about the energy leaving the system? We have work plus P2 plus K2 plus U2 plus EF2, or that is work plus P2 plus K2 plus U2 plus E2V2, or the same dasad siya gihapon class. Sorry. This is now, we will substitute the quantity internal energy plus PV with enthalpy H. That is the energy leaving the system. Now for the energy balance, so for the energy balance, we have delta E of the system is equal to energy entering minus energy leaving the system, right? And so delta E of the system, so kaning entering nato is heat plus P1 plus K1 plus H1 minus the energy leaving is work plus P2 plus K2 plus H2. And so this is now heat minus work minus delta P, that is P2 minus P1 plus delta K, K2 minus K1 na siya, plus delta H. Okay. So delta E of the system now is equal to heat minus work minus delta P minus delta K minus delta H. Or rearranging, heat is equal to delta E of the system plus work plus delta P plus delta K plus delta H. So this is applicable for steady and steady flow. For steady. Now, for steady flow lang alone, your delta E of the system is equal to 0. So that is why ang atong equation now will become heat is equal to work plus delta P plus delta K K plus delta H, or Q is equal to work plus delta P plus delta K plus delta U plus delta Pb. Okay. Now for fluid flow through pipes. So this is an example of an open system. Fluid flow through pipes. Suppose we have this one. We have this as our pipe. This is our point 1 and this is our point 2. And then let us have the following assumptions. So for this illustration, let us assume your heat to be zero, your work also 0, and your internal energy point 1 is approximately equal to internal energy at point 2. Therefore, your delta U is also 0. Since this is an open system and steady flow sad siya, now our energy balance is, unsa to energy balance nato? Heat is equal to delta P plus delta K plus delta H plus work. And so heat is equal to P2 minus P1, that is for delta P, plus K2 minus K1, that is for delta K, plus H2 minus H1 plus work. And sa atong assumptions, 0 ang heat and work. So this is now P1 plus K1. So gitranspose nato H1 is equal to P2 plus K2 plus H2. So P1 plus K1 plus your H is U plus PV, right? So P2 plus K2. Again, your H is U plus PV. So this quantity. But sa atong assumptions, your delta U is 0. So cancel out. So our equation now is P1 plus K1 plus P1V1 is equal to P2 plus K2 plus P2V2. Now, formula to get the potential energy, that is mass times gravitational acceleration times the elevation. How about for kinetic energy? That is 1/2 mv squared. mv1 squared plus p1v1. This is mgz2 plus 1/2 mv2 squared plus p2v2. Now let us let us divide the whole equation by the product of mass and gravitational acceleration so that you can cancel this one. We have now z plus cancel ang mass. So this is now v1 squared over 2g plus p1 v1 over mg is equal to z2 plus 1/2 v2 squared over 2g plus p2v2 over mg. Okay, this one z1 plus v1 squared over 2g. Now kani siya class diba this is kani siya mass and volume over mass. From definition of density is mass over the volume. So mass over the volume. Now so therefore kini day siya is the reciprocal, V over M is the reciprocal of density. So that is P1 density diri density G is equal to Z2 plus V2 squared over 2G plus P2 over density G. This is 1. This is 2. For incompressible fluids, so such as water, for incompressible fluid, that means the imuhang density is constant. So density at point 1 is just equal to density at point 2, or rho. So ang atong equation now, Z1 plus V1 squared over 2G plus P1 over rho G. So there is 0, 1 o 0, 2, the same na. That is for incompressible fluid. Z2 plus V2 squared over 2G plus P2 over rho G. So this has now become the, what you call, the Bernoulli's equation. This one. So when we say Bernoulli's equation, we have here the definition, Bernoulli's principle. The energy of a flowing fluid per unit time passing any upstream section is the same in energy per unit time passing any downstream section plus the loss of head between the two sections. So note that Bernoulli's principle applies only for incompressible steady flow of a fluid with no internal friction, so no viscosity. Okay. So with the loss of head, or by the head loss, okay, so we have now the Bernoulli's equation. Ito yung apil ang head loss. Ay, sorry, this is 1. B1 is equal to Z2 plus V2 squared over 2G plus P2 over rho G, then plus the head loss. This is now the Bernoulli's equation. So, unsa man sila, by the way? This is in terms of head class, where your Z is called the elevation head, or the static head. In ang unit na to ani, since in terms of head man ta, is the unit of kaning feet or in meters. That is the elevation or the, again, that is elevation or the gravitational head, dili static. We have V1 squared over V squared over 2G. V squared over 2G, that is what you call now the velocity head, or the dynamic head. So again, that is in units feet or meters. We have P over rho G. By the way, ang kaning rho G nga quantity, or P over gamma na siya, no? Because density times gravitational acceleration is equal to gamma, or the specific weight of the fluid. That is what you call the pressure head or the static head. Ang elevation head, that is the gravitational head class. Again, in feet or in meters. And HL, of course, that is your head loss. The head loss. Still, kanyang mga losses ba due to friction. So, depende kung i-include siya sa problem, so you include it. Pero kung wala, you can consider it as 0. Okay. Examples. An internally reversible process occurs in a system during which heat is equal to negative 12 kilojoules, delta U is negative 79 kilojoules, and delta H is negative 111 kilojoules. So first is to find the work if the system is non-flow. By the way, let us write all the given data in this problem. So what are given is first is the heat, which is negative 12 kilojoules. You have the delta U as well, negative 79 kilojoules, and the delta H, which is negative 111 kilojoules. So sa letter A, you are to find the work if the system is non-flow. So gi-state siya that non-flow. So work non-flow ang gipangita. So meaning to say, considering sa letter A nga problem, that the system is a closed system. Okay, so energy balance for a closed system, we have heat is equal to delta U plus work non-flow. Diba? Mao ni energy balance sa closed system. So work non-flow, therefore, which is magipangita sa problem, is heat minus the delta U. This is now given, which is negative 12 minus negative delta U, 79. So work non-flow, therefore, is negative, positive naman din yun. So positive 67 kilojoules, negative 12 plus 79. So 67 kilojoules. Okay. Now for letter B, determine the shaft work if the system is steady state steady flow with delta K 4 kilojoules. So we are to find the work. So this work is work steady flow. Okay, indicate man sa problem, steady state steady flow. So this is an open system. So energy balance for an open system, heat is delta P plus delta K plus delta H plus the work. No, mo ni ang work nga itong ipangita, work steady flow. Work therefore is equal to heat minus delta P minus delta K minus delta H. So heat nato is negative 12. Delta P, wala gi-indicate sa problem na natay delta P, so this is 0. Delta K is naa 4. And delta H is negative 111. So, ang imuha na karong work, steady flow, this is 95 kilojoules. Okay. And then lastly, we have letter C. Using the conditions stated in B, calculate the integral of Pdb and the negative integral of Vdb. So, kaning integral of Pdb, this is the boundary work na formula. So, sa tuang previously, we have work non-flow is equal to the boundary work plus other forms of work, right? In which case, dire wala man tay other forms of work sa gi-indicate. So, therefore, we have work non-flow is equal to the boundary work, which is equal to integral of Pdb. Therefore, the integral of Pdb is whatever the answer sa imuhang work non-flow, which is 67 kilojoules. Okay. And then letter C again, find for the negative integral of Vdp. So, from from the relation sa H, enthalpy is equal to the sum of internal energy plus PV. And so you have now the differential dH is equal to du plus dPV. Or this is now dH, ito na siya integrate plus du plus integral of Pdb plus integral of Vdp. And so, kanin siya matong ibalhin sa pikas so that we can have the negative integral of Vdp. Ibalhin nato na siya sa pikas. So, this is now delta U plus delta plus ba? Minus. This is minus delta H plus integral of Pdv. So, substituting values, delta U is negative 79 minus delta H minus negative 111 plus integral of Pdv which is 67. So negative integral of Vdp now is equal to, this is now 99 kilojoules. Now, ang work non-flow is equal to, simply equal to this one, integral of Pdv. Also, ang work steady flow, kung tanaw na ito ang relation, work steady flow, ang kanisiya, kung tanaw na ito, work steady flow plus kini delta K is equal to negative integral of Vdp. Pero kung wala gani, zero ang delta K, ang ato ang work steady flow is just equal to the negative integral of Vdp. No? Ang work non-flow is equal to the integral of Pdv. That is if other forms of work is missing or wala, zero. Ang work steady flow pod is equal to the negative integral of Vdp. That is if only zero pod siya to ang delta K diri. But since natay delta K plus work steady flow is equal to the negative integral of Vdp. Okay?